Okay, hold on. Okay. Hello and welcome to another episode of Flying High with Flutter. I'm your host, allenwyma. And before we start, I wanted to give a quick shout out that we have a current course right now. So if you're interested in writing Flutter apps and adding some Rust to your Flutter apps for performance, bringing in extra libraries that just aren't in the Dart or Flutter ecosystem, you can go ahead and check out the course. The course is at rustwithflutter.com. Again, it's rustwithflutter.com. So, again, back to the show. Today I have a special guest. It's Brenden Matthews. He's an author of the book called, I always get this one wrong. It's called
Code
is
like a
Code
pro.
Like a Pro. So the title of this episode is Rust Like a Pro. I think I wrote that one wrong, but it's Code Like a Pro with Rust, if I remember correctly. Uh, I don't know why, but the title always messes me up. But the book itself is fantastic. I still think I'm a beginner rust. What do you call it? Beginner rustation. But in any case, I've done a couple of things in production with Rust. Super happy with it. I love the performance of it. But I always feel like I cannot write idiomatic Rust code, but you call it rustaceous code, I believe we talked about. So we had to
Yeah.
talk on the other so I have another podcast I do called Rustation Station. And so if you're interested in Rust stuff, you can check that podcast out. And you were just a guest on there, on the recording at least yesterday. That episode's not released yet. But yeah, sorry. I'm doing too much talking now. It's time for you to take over and kind of talk about yourself for a moment. Go ahead.
Um, yeah, sure. So, my name is Brendan, and I've been writing software for 20 years or so. Uh, I got into Rust probably 5 or 6 years ago, I would say, um, and I sort of fiddled around with it for a while. Um, but it wasn't until I guess around 3 years ago that I started trying to actually 3 maybe 4 years ago I started trying to actually build things in Rust, and very quickly I learned that um, it's it has a bit of a steep learning curve, and it's a little tricky, um, and like you mentioned, it's pretty hard to figure out what the idiomatic way to do things in Rust is, or the rustaceous way. So that's a big part of what my book is about, and you know, I'm hoping people find it helpful.
I really found it super helpful. Like, there's a couple of concepts to me that stuck out, like talking about which kind of components to add, right? So um, when you use Rust, it's kind of bare bones, which I think that's part of the Rust philosophy is like don't bring in things that you don't really need. So you have to kind of start saying, okay, if I'm going to actually be writing Rust and writing good Rust like a pro, I probably need to add in a couple of things such as cargo expand, maybe Rust FMT. I'm not too sure. Like, as somebody who's been writing Rust code for quite a few years, like, what's in your tool belt when you have like, if you have a brand new computer, you're installing Rust up for the first time. Like, what do you try? How do you set up your machine?
That's a good question. So I guess to answer that, you have to maybe think about what your workflow is, and I'm going to assume that most people fall into um, either the category of people who like to use some sort of integrated development environment, IDE, like VS Code or something. That's that's one set of people, and then the other set of people are people who are maybe a little more traditional and prefer to just use a plain old text editor, and just write the code, which is how I was for a long time. I sort of rejected IDEs, and I thought that they didn't add much value. Although these days I've changed my mind on that. But if you are going to go down the IDE route, then um, beyond rust up and basic cargo, there's a bunch of stuff that can make your life easier. Like specifically a tool called Rust Analyzer is basically the language server implementation for Rust. Actually, it's one of two. This is a little bit confusing, and I try to make it clear in my book, but there's basically two competing implementations in Rust. There's the Rust language, RLS, yeah, Rust language server, or RLS, which is like the quote official one or whatever. And then there's another competing implementation called Rust Analyzer. And I think strictly speaking, Rust Analyzer is still labeled as like beta software, not fit for use. But in practice, I've found that Rust Analyzer is much better than RLS. So you're better off just using the beta software in this case. So that's Rust Analyzer is probably the first big thing. And then beyond that, there's like a long list of tools that sort of bolt on to Cargo and the other Rust tools, which you can use. I mean, some of these are things that you would use continuously, while you're working with Rust code. Some of these are tools that you'd use occasionally. Like, for example, you mentioned Rust Expand, which is it's basically a tool that will pre-process the Rust code and show you the expanded version of it. And this is really helpful if you're trying to work with macros in particular, right? Because like Rust has a macro system, and if you're trying to, the macros essentially generate Rust code based on your code, and if you're trying to debug those macros and see what's going on, then Cargo Expand lets you see what the result, like the expansion of those macros looks like, and that's super helpful. But whether it's Cargo Expand or some other tool, a lot of these things are sort of designed for working around particular edge cases or whatever. Another one that's useful is Cargo Tree, and that's for examining like the dependency tree in your package. And there's a bunch of them. There's one, there's tools for like code coverage, for example, to generate the coverage reports for CI systems, and a bunch of other things. But the first thing that I would do to set, if I'm trying to set up an environment, I would set up, I'd install Rust with Rust up. Then I would install VS Code and Rust Analyzer, and then Rust Format and Clippy are the sort of the quintessential Rust tools, in addition to like the whole LLVM suite, which gives you like a debugger and all that stuff. So yeah, hope that answers your question.
When you say LLVM suite, like is part of like those Rust up components?
So no. So when I say LLVM suite, I mean LLVM itself has a bunch of tools like a debugger, for example, right? And if you want to use the debugger, one way to use it is through VS Code, and so if you set up the Rust tools, then you can run the debugger just like you would in any other environment, and like watch variables and step through code in VS Code, a line at a time or whatever. Set breakpoints, all that. And so all of that is done through the LLVM suite, which includes LLDB, which is the debugger. And then, the reason all that works is because it hooks into like the LLVM tool set that lets Rust sort of like piggyback on the LLVM, like the whole tool chain. And in addition to that, there are other tools that LLVM includes, for example, if you're doing testing and you want to do fuzz testing, there's a library called libfuzzer, which is part of the LLVM project, and you can again there's a cargo tool called cargo fuzz that hooks into libfuzzer and allows you to generate like boilerplate for Rust unit tests that use the LLVM fuzzing framework, basically. And then this isn't exhaustive. Like there's a lot of stuff, and I definitely don't have an exhaustive list of all the things you can use, but I've done a collecting what I think are the most useful and most valuable ones, like the tools you most likely want to use. But not everything is necessarily there, right? Like one tool I would say that's kind of missing that I wish existed, which I haven't found like a comparable equivalent to, is something like Valgrind, which I don't know if you've encountered, but like I used it a lot back in my C and C++ days for you can do quite a bit with Valgrind, but I'd say that the two main use cases for it are finding errors and race conditions. However, I would say the whole point of Rust is to maybe avoid ever having to use a tool like Valgrind, because you shouldn't really have memory leaks or race conditions if you're doing things right. So yeah, that's
interesting because I thought the whole like backbone of Rust is that it prevents these types of errors because it can actually check for these specific things that you mentioned, right? Memory safety and race conditions. Because I
yeah.
remember like I watched this guy on YouTube who was he coded up something in Go, and as soon as he ran it, it crapped out on a race condition, and he tried to write a similar program in Rust and it wouldn't even compile from a race condition.
Yeah, that's true. So, I mean, I would say there are sort of two versions of Rust. One is the idealized version, which is based on the idea that you can build any type of software using perfect idiomatic Rust and never have to use any of the escape hatches, like the unsafe keyword specifically. Um, that's one version of Rust, and then the other version of Rust is sort of the reality of like the rubber meeting the road sort of Rust, where you have to contend with the fact that sometimes you need to use a C library, or sometimes you have to like allocate memory in a weird way. Um, and while I wish it wasn't true, I think you have to sort of be realistic in that, or realistic and sort of recognize that there are going to be cases. If you do a lot of Rust, there will eventually be a case where you have to either use one of these escape hatches or unsafe code, um, and that's really just a function of how much time you spend writing Rust, what level of complexity you're working at, and so on. So I don't recommend, you shouldn't reach for unsafe code, and you shouldn't be trying to do like custom memory allocation or anything like that. Um, but you still might have to do it, right? Like the thing the thing that Rust can't do is really change certain fundamental aspects of how a computer operates, right? Like there's sort of, and people have debated this kind of stuff in computer science, sort of like in an academic sense before, about like the sort of like the idealized computer science, I don't know, philosophy or whatever you want to call it, versus the reality of how the von Neumann architecture works, where you have like a CPU and memory and a disk, um, uh, and how concurrency actually works in the system, and so on. Like those things still exist. They're concepts that can be abstracted, but if you're writing a Rust program and you're using threads or what have you, then you know th- there could be a case where you have a race condition, especially if you're doing I/O or something. Not, I mean, not if you're doing it like 100% the like safe way, but in it could happen. I'm not saying the language is flawed. Let's be clear. If you write 100% like idiomatic safe Rust code, then you'll never have a race condition or a memory leak. But the moment you need to use a library that's not written in Rust and includes some unsafe or whatever code anywhere, like all those guarantees are basically gone, right? And so unless you can rewrite 100% of everything in Rust from scratch and never use a C library or whatever ever, then it's pretty tough to make that guarantee. So I guess that was a long-winded way of saying, like, yeah, you're right. Like perfect Rust doesn't have those errors, but there's no perfect anything, right?
Production use cases are always going to far outweigh example use cases.
Yeah, and sometimes it's just not worth the pain of like sometimes it's not worth the pain of achieving the perfect code versus the convenience of just using an escape hatch, right? Sometimes you just got to ship the code, and you don't have time to make it perfect, basically.
Now, if you're going to be doing Rust like a pro, does that mean you'll probably have to end up encountering doing a lot of FFI then?
Realistically, I don't think so. Um, well, so I'll try to answer this question with like a personal story about Rust, which is that one of the few libraries that I wanted to use like somewhat recently that I couldn't find a pure Rust implementation for was the libsodium library, which is like excuse me, a cryptography library that it just includes a bunch of general purpose cryptography tools, and it's written with an API that's designed to be like ergonomic and relatively easy or painless to use. Additionally, it's designed, the API is designed such that it's hard for you to do cryptography wrong, which is something that's easy to do. Um, and the I think the most popular implementation of this library right now in Rust is called sodium oxide, and all it is just a wrapper around the C library, the actual like libsodium C library, um, and I wanted to use this, but I wanted to use the pure Rust. I wanted like a pure Rust implementation of it, um, and there are a few sort of random crates here and there that implement bits and pieces of the libsodium library, um, but there was no complete implementation of the library that basically had the same API, um, but didn't depend on any C libraries. So that's that. You know, I went and I re-implemented that in pure Rust just so that I wouldn't have to include that C library, basically. And there are lots of these. You know, I'm picking like a specific example of libsodium. The library I wrote, by the way, is called Dryoc, like DRYOC, which stands for Don't Roll Your Own Crypto, which is sort of meant to be a joke because the library itself is basically a case of rolling your own crypto, right? I hope somebody else gets the joke, but I don't know. Anyway, although I didn't create any like new cryptography in it. I'm just re-implementing existing well-known cryptographic functions. But my point is that like with the way that the Rust ecosystem works, like I think if there are any C libraries that still exist that don't have pure Rust implementations, your options are either that you just wait or you can just go and rewrite it yourself, basically, which you know some people might be up for, some people might not. But I can't think of many libraries where that's something you need to worry about. Like, I guess the exception would be if you're working on platforms like, I don't know, maybe Android or something, and you're trying to call functions from like an SDK or something. In that case, yeah, you probably will have to use FFI. Um, and again, that's gonna like sort of break the safety contract. But I think the way to work around that generally would be to design a plugin architecture. Basically, instead of writing some Rust code and having it call some library, you would design your thing as a plugin, and you would have the plugin sort of loaded into whatever needs to use it, and then you know hopefully essentially go the other direction, like pull your Rust code in, and call that. And there's actually like some libraries already for other languages that make that relatively easy to do, like with Python or you know whatever. There's probably a Java one, but or you know Java or Kotlin or Dart. Although I'm not sure. I'm not sure what they are off the top of my head.
Yeah, definitely. I'm kind of wondering, like, what should people be exposed to, or at least be prepared to be exposed to? Like, for me, like, in Dart, I don't have any examples, but I'm a pretty big user of Elixir. At least I did a lot more before. Now I'm doing a lot more Dart and Flutter. Um, like, my personal opinion is that like Elixir is kind of like the baby kind of derivative language from Erlang. And if you want to know how to write really fantastic, scalable Elixir applications, there's not a lot of materials specifically written in Erlang, or sorry, specifically written in Elixir, but I would probably look to Erlang, and there's quite a few books about scalable applications using Erlang. So the syntax, of course, is different, but you can still read it once you've done enough Elixir. So you can take a look at um, Erlang books that talk about this, and then get the ideas, and then try to translate that to Elixir. But I'm just wondering, like, what about like for Rust, right? If I want to write really like performant, great looking Rust apps, should I look at C and C++ code to have an idea about what would be good and what would be not so good, or would that kind of throw me off my path?
Um, so that's a good question. So it's interesting you mentioned Elixir because there's a library from I think Spotify, um, and I forget the name of it. Uh, and the library is for um, including Rust crates in Elixir code. Uh, the reason being that the Erlang VM is very slow when it comes to very specific um, types of computation. In particular, doing math in Erlang is pretty slow. And when I say slow, like I don't know exact, but let's just say it's like 100 times slower in Erlang than it is to do the same thing in Rust. So I believe it is Spotify. Don't quote me. I'm doing this off memory, but
About Rustler, right? And I don't know if that one's by. I just did a quick Google search. I couldn't find anything on that, but I do know that there's a library called Rustler. That one is how to bring Rust code into your Elixir apps by the way of something
uh,
called a NIF. Is that the
yeah,
one you're
yeah,
talking about?
that's the one. I thought that was
Okay.
the Spotify project or something. It doesn't matter, but yes, that's the one. Rustler.
Okay. Yeah. That's actually the
Um,
one. That's actually the first time I ever used Rust. Is I used Rustler
oh, I
in
see.
production.
Interesting.
So yeah, I've had a lot of fun with that. Let me let you continue on your way. I just want to make sure we got the right one for the audience, in case there's anybody else who's looking at this. Sorry, go ahead.
Yeah. So um, Rustler. I guess I'm just looking at their GitHub page right now. The example they give here is to implement an adder, because if you're trying to adding, well, I think just literally just doing a plus b might not be a good case, but if you're trying to do something moderately complex with math in um, Erlang, then you might be better off like trying to offload it to something like Rust. And it doesn't have to be Rust, like it could be C, but why use C when you can use Rust instead? So yeah, uh, this is exactly what I was talking about. But so with Elixir in particular, you could probably imagine cases where you want to I don't know. I'm trying. Actually, a good example might be cryptography, right? Like, in fact, I believe the Erlang VM implements a bunch of cryptographic functions for you, but I'm gonna take a guess and say that like the ones that are currently available um, in the in the Erlang VM are like is like a pretty small list of functions. So if you wanted to use like I don't know some like crazy hash function or something like Blake 2b or something like that, which is like some hash function. I'm going to take a guess and say that Erlang doesn't have Blake 2b. Maybe it does. I don't know. Let me look it up. Erlang Blake 2b. Does it have it? Um,
Two, but I don't know what is Blake 2B.
Blake 2b is just like a slightly different version of it. There's basically like a bunch of different variants of these hash functions, and um, each one just has like a little tweak. But yeah, there's like a Blake 2B, there's Blake 2S, 2BP, 2SP, and a bunch of other ones. And there's also a Blake 3 now as well. But anyway, my point is if you want to run like one of these hash functions and you want to implement it in Erlang, it's probably going to be super slow. Which, by the way, might actually not be a bad thing, depending on what you're trying to do. But it might be like so painfully slow that like it's obnoxious, I guess. I guess maybe a hash function is not the best example, but say
I can give
just
you
like
my
any sort of
example if you like.
yeah.
So
I
since
mean,
this happened to me, well, let me just give my production, right? So you're kind of giving like a, what's the term? I forget what the term is, like a anecdote or whatever, right? Kind of example out of
yeah,
your head. So what actually came up to me was I had a client project which was about 100 plus XML files I had to go through, and pending certain conditions, I had to go up and down an XML DOM or whatever you call it. And so that in Elixir parsing XML, the best one I could find, the easiest one I could find at least, was Sweet XML. And for some reason, the memory blew up like about 4 gigabytes or so, 4 gigabytes plus, just from all the parsing of these things. And so that was just insane. And also the processing. So it went from like 10 minutes of processing time to about 4 gigabytes of RAM. And it was embarrassing to ask my client to say, hey, could you please add more RAM to your machine because my algorithm is not so performant. That kind of made me look like not that great, right? If you're having this kind of stuff, not like a pro. I guess we can kind of lean back to your book. I took some time. Like I took a risk because when I did this at the time, Rust was still new to me. I kind of played around with it. Really was excited to go get into it. Never really had a chance. So I took a pretty big risk for this one, and I rewrote one out of two. So there was like two different types of files I had to process. So I had two different algorithms. One was pretty straightforward. Like you just go through the file and just as you're parsing each line, you could just pull it out. The other one is I had to go up and down the tree, right, to grab certain things. And so I did that second one, the latter one, with Rust using Rustler. And the entire processing time from end to end went from 10 minutes down to 10 seconds. And memory was like in the megabytes because it was just being released like right away, because of the way that Rust works. So like that's a production use case that I used for sure. And it was, yeah, definitely one of the best choices because it was faster than the another guy. They did PHP over there. He did an implementation and his was like pretty fast compared to mine. But mine was, yeah, he couldn't compete. Like to restart the server actually took the longest than it did actually parsing everything end to end. So that's a real life production use case, and that's just so basically parsing XML files with at least Sweet XML. It's just not as performant as you can with Rust.
right. Yeah, I would say that is definitely a compelling case for Rust. Even if you don't want to go like all in on Rust, for like your typical web service, I think a language like Elixir is probably going to be more productive most of the time. Like you know, I I I I can't imagine Rust sort of becoming the replacement for like Ruby on Rails and PHP and Elixir even. I just I just I can't imagine that. But what I can imagine is that those frameworks start to include a lot of pieces that are just um, like small parts built in Rust because you gotta you have to like always balance the trade-offs of the amount of difficulty involved in writing something in Rust versus like Elixir or PHP or Ruby or Python or whatever, um, and whatever potential performance or safety implementations or sorry implications there might be from doing it in Rust. And like it's cool if you can write everything in Rust, but I would say it's not as it's definitely not as easy to write things in Rust. It just isn't as much as I would like it to be. Like it takes longer just because you have to you just have to worry about a lot more stuff basically to write the code. Whereas in languages that just do like automatic type inference and whatnot for you, um, you don't really have to think about it so much.
Is that there's still a lot of tooling and a lot of things that come out of the box. Like since we're still talking about Elixir, like there's this thing called the Erlang Observer, which gives you a lot of insight about like which pieces of your system may be running too slow or are running too much. They may be hogging up the system, or where you have too much memory being used or allocated, things like that. And that's just built into the VM itself. So this type of like when people say tooling, I think about this kind of tool rather than like cargo or these kind of extra things that help make life easier. But yeah, when you have like a system that has a VM, like you can hook in a lot of these niceties. Like the JVM obviously has a lot of this kind of stuff too, where you can start debugging like, okay, which threads are being bad. Whereas I don't know, I haven't played with JVM so much that I can do this kind of stuff, but I'm guessing you can do some really cool stuff. For something similar, you have to look at like Tokyo Console. I haven't looked too much at it, but that's very specific to a very specific runtime, and that will probably only help you on Tokyo related issues rather than like your entire system. If you write the whole
Yeah.
system in Rust, you don't have that kind of tooling because you could be rolling something totally customized that people just didn't make anything for.
Yeah, I mean, I would say Tokyo is fairly low level still. Compared to something like Erlang, um, or Elixir. The in particular the concurrency primitives that Erlang slash Elixir gives you is uh, really top notch. Um, Top notch in that it's it's easy to use, easy to reason about, um, works really well, and has been like very much battle tested. Um, and while you can sort of be achieve the same behavior in Rust, I don't think that you can really do it yet at the like at the same level. Same level, I meaning like you can't achieve the same like performance trade off, um, without having to do having to like think much harder. I guess it's like a higher cognitive load, um, but not impossible. And Rust has improved a lot, right? Like with the async, it's much easier now than it was. Um, but now, I mean, currently the problem with async and Rust is that you can't mix async and not async code really, um, not without a lot of pain. And so it's not, and I think it'll get better, but at least right now the way it's implemented, um, you you can't easily um, or you can't easily achieve concurrency like in all cases in the way that you can with like the Erlang VM, for example. Um, uh, but I don't know. Eventually the libraries will add async support, and hopefully everything will be great. But it's not going to happen overnight.
Okay, maybe we drifted off a little bit too much off topic, but I think the topic we went into is quite interesting. Um, like, okay, so is there kind of things that I should be prepared for, like if I was a beginner programmer to if I'm advanced, like let's say like or like a pro, right? Like the thing that comes to the top of my head is Do I actually have to write macros? Because macros in Rust is really quite, it's like cryptic language. It's like Chinese or something. It's totally out there when I look at writing a macro. It's hard for me to understand. Like, do I have to write macros if I'm going to be a pro?
So you don't have to write macros, but I would say that learning them is beneficial if you're going to be spending a lot of time doing Rust, just because they can save you a lot of typing and boilerplate. Um, Rust macros are actually super powerful because you can they're basically like um,
Oh yeah, what a macro is because we don't have this type of macro in Dart. At least I haven't seen or heard of one before.
yeah. So there are two main types of macros in Rust. One is basically like the default whatever macro. I forget what they call it exactly, but it's like the basic macro, um, and that is just simple code substitution where you can define like like what are the parameters into the macro, and you can specify like what kind of parameters they are, like is it a variable or is it a type, and so on. And then you can define a block of code, and then it basically just like performs the substitution in the block of code, right? That's the first type. And then there's another type of macro, which is procedural macros, and these are like advanced level macros. Um, and with procedural macros, you can programmatically construct the code basically, and these are these are pretty complicated. They're not that complicated, but you you basically read in the input arguments basically to your macro. You have to write the macro, and in writing the macro, you basically have to build out the syntax tree um, in code, in Rust code. And there are some libraries that make this easier, whatever, but it's definitely more complicated, right? Um, but it's also like super powerful. Like the way to think about it would be, imagine if you're writing a program that writes your software instead of actually writing the software yourself. And it's not as simple as just substituting variables, because you need to say like, if this parameter, then write out this code and substitute this thing here. And if this parameter says this, then do this over here. Um, and so like those types of macros, procedural macros, can get quite complicated and quite elaborate. Uh, um, but you don't need to learn them. You don't need to use them to use Rust. I will say that there are some libraries that use them pretty extensively, and it sort of looks like magic when you look at them from the outside. But that's where tools like Cargo Expand come in handy, because you can basically use the macro, run Cargo Expand, and then it'll show you the expanded version of the code that the macro is generating, so you can get an idea of what's actually going on with the macro. I should mention that Rust macros are nothing like C macros, for example, which like C macros are like strictly just substitution, and like you can with C macros you can have like syntax errors in the macro, and the preprocessor will just substitute it, and like it's not going to tell you that your macro doesn't make any sense, blow up. But not in a very helpful way, basically. So, Rust macros are a lot more sophisticated than that, for sure.
To know about macros is they're actually compile time, right? Because there's different types of macros out there, I think, and these ones are compile time. That's why you can use tools like cargo expand to see what is the final outcome. So, but those.
Yeah, I mean,
Mhm.
they're compiled time, but it's still being pre-processed, right? Like the macros get expanded before the final code is compiled. Um, Meaning you can you can have a macro, for example, that defines a struct, and then use that struct in your code that you know didn't exist before you ran the macro. Um, but like the Rust tools are smart enough to figure that out and you know work with it basically.
The one thing I found quite interesting is like the amount of macros in a Rust program is quite a lot. Like most other languages I see, they don't really make quite a lot of use of macros. Or, I mean, you see it a lot, but it's actually more of a syntactic sugar slash what do you call that? Domain DSL kind of domain
Yeah,
specific
yeah,
language.
that
So like we go back Elixir, right? If you're writing a Phoenix application, there's a lot of these kind of macros that actually happen that make life easier because it's like, okay, if I want to do a get request to say get and actually underneath the hood, I think the get one is like doing some funky stuff. So that way, like when you read it, it's very clear. But when you have to implement that by hand, it's not. But there's some macros within Rust I think are actually easier to have just written out. Like I had this discussion with Carl Lurch on the Rust Station podcast where I was telling him my kind of concerns about macros. Like, yeah, okay, it makes life easier, and I think they make sense. But some macros I think are a little bit overkill. Like when you want to do an async program in Tokyo, right? You have that one that goes on top of the main. But if you expand that one out, it's just a call that says, okay, block on and run it. And I thought that particular one was a little bit too much, and I kind of like the full syntax of writing an async main intro, and what do you call that? The intro into the async kind of domain. I think that one would be a little bit nicer to be written out all the way because it wasn't that much code, right? But sometimes the macro can do quite a lot. So sorry, you're in the middle of saying something, but I just kind of wanted to state my opinion about this.
yeah, no, that makes sense. I would imagine that like from using that example from the Tokyo author's point of view, I think the issue there is that they want to be able to um, maintain like forward compatibility. So if they wanted to change something about you know like main or whatever in the future, then by just sticking it in a macro, they know they can just like change it in the future, and everyone's code gets updated. Um, but yeah, I mean, I guess like macros are one of those things that you can definitely overuse because they are in a sense like kind of like a DSL. It's like you're basically replacing a block of code with like your own separate code where someone is just like plugging in the parameters and then it's filling out the code for them, right? Um, and so yeah, that's not always the best thing. There's like some examples of this are the like the derive macro, for example, if you're familiar with that, which lets you like implement a bunch of things like debug, clone, debug, clone. What else? There's a bunch of them. I'm not thinking all of them right off the top of my head, but you see that used like all over the place, and the problem with it is that like the language then becomes the macro, not the actual thing, right? Like you see derive debug and like, I know that it makes it so that I can print the like debug print this structure, but I don't, I forget I'm not even sure exactly what it's doing, right? It's like you forget what's going on because the the macro is sort of obfuscating the code, like the result. Um, that definitely happens, right? Because like right now, off the top of my head, like I mean, I could probably implement like the debug format traits myself, but um, I can't picture them in my mind. I'm not sure what they look like because I don't know if I've ever written them. I've always just used the derive debug thing. So yeah, I mean, there's a downside to it. It's definitely a shortcut, but on the whole, I think it's a powerful tool. Um, you could definitely take it too far, right? Like theoretically, you could just have a Rust program that is entirely within a macro, right? Uh, just as like an exercise, just for fun, you could do that. You could write your whole Rust program in a macro, and then you just like put the macro in your main Rust file, and like there's your whole program inside of a macro, which would be kind of pointless, but you could do it.
Yeah, definitely. Um, let's see, where were we? Yeah, so I mean, yeah, the audience of this podcast, they're really from my. I just look at the numbers, right, when people download because I can't see too much other than people reach out to me. I've had discussions with quite a few people saying, okay, we're really interested in using Rust and Flutter and just in general, people are just interested in Rust and by itself, even without Flutter. Um, so like, yeah, I mean, maybe we could talk more about like why people should take a look at your book, right? Because I think most of the people on this podcast are going to be beginners, but some may be looking to level up or they want to know what's the next stage. So I always hear that if you're a beginner, read the Rust book end to end, do a couple of sample apps, and then you should be in a pretty good state. And then like, what would be the next kind of step?
Yeah. So I would say first of all, if you are a beginner, my book is probably not the right place to start. But once you have familiarized yourself with like the basics of Rust, and you can compile a program, um, like write some simple programs and stuff, then um, my book would probably be worth your time. Um, the point of my book, Code Like a Pro in Rust, specifically, is to help people get past sort of like the initial phase where I've been through this many times where like you learn a new language and you kind of get a handle on the syntax, um, and then you go out and you try to like actually make things in that language, and you find out like you don't actually really understand what's going on, and it's a little difficult to actually build things because even though like you see this, you understand, sort of understand the syntax or whatever, you still don't really get it, I guess. And so my book is about like kind of like fast tracking you through that part where basically going from a beginner to like through intermediate and to advanced as quickly as possible by um, teaching you about all the things you really need to know to be productive that you don't find in the typical like Rust introductory book or tutorial or uh, anything of that sort. And I think like one thing that a lot of books don't cover usually is tooling, for example. So I spend a lot of time talking about cargo and the tools that you use with cargo, as well as the tools that you would use in an IDE like VS Code. And you can sort of save yourself the effort of having to like go and try all the different tools and figure out like what you should be using the hard way. Instead, you can just, like, here's my prescription, just go start using these. And, if you have different ideas later on, you can do things differently, but you don't have to waste a ton of time, at least getting up to speed. And then, I focus on like the stuff, basically like the touch points, the things where you're going to be spending the most time, right? Like, for example, I have a chapter just on data structures, and it's not like an exploration of data structures in like the computer science sense, but just like what Rust has, and like which data structures you should be using, what you should be using them for most of the time, and like what kind of stuff you shouldn't be doing, I guess. And it turns out in Rust,
Just want to interrupt a moment. Like, what I liked about the best about that chapter that I think you're missing out on is kind of giving a quick introduction about like what each one is for, and which one you should focus on. And also, I think you kind of said that like some of these are built upon others, right? Like I think the vector is like also working with or powering some of the hash map or something. Is that right?
That's right. Yeah, yeah. I mean, in Rust, like most of the time, the right answer is to just use a vec or a vector. Uh, the vector is like highly optimized and already has all the features you'll need most of the time. And even though there are hash maps and like linked lists and all this, in practice, there's rarely any benefit to using anything other than a vector in Rust. And so it would make sense if you come from a different language, like, I don't know, take like a Python or something, where you might be used to using dictionaries all the time, right? It turns out like you might not want to do that, even though like Rust has hash maps and whatnot, which are fine. They're fast too, but you just use different patterns, I guess. And vec is just like the most convenient most of the time, easiest to work with, and it's very fast. So you also have to think about data structures a little differently in Rust, because there are really only two ways to allocate memory on the heap in Rust. One way being with a vec, and the other way being a box. And so, like you mentioned, it turns out that when you do use these other data structures, oftentimes it's actually just a vec underneath, because that's how the language allocates memory, basically, is using a vec. So yeah, I mean, sometimes there's just no point. Oftentimes, it's faster to just scan a vec and than it is to try to do a lookup on something else. So yeah.
Yeah, definitely. Yeah, I had no idea that a vector was underneath a hash map. I think that's pretty interesting. So yeah, like I said, your book is pretty insightful for somebody who's, I've been coding for a while, but I didn't know you could do this kind of stuff. So there's just, it's quite interesting a language, right? Yeah, so I mean, for your book, right? Maybe we can start to wrap up over here. For Rust, right? So this the book would be good for somebody who's already like pretty comfortable with Rust and just wants to kind of get a little bit deeper. So maybe like an intermediate kind of level.
Yeah, I would say like beginner to intermediate. If you consider yourself an advanced Rust like developer, then um, there's probably gonna be less in my book for you. Um, that's not to say there might not be interesting stuff in there. I would hope there's something for everyone. Um, I think I mean, personally, I think the most interesting chapters are on um, the um, like design patterns in Rust because these chapters, yeah, I don't think any of them published yet, but um, I think it's the most interesting stuff because um, there isn't there isn't much out there like in the sort of the Rust land yet on design patterns in Rust and like you know what are the standard design patterns and I don't know if everyone has read like the old design patterns book. I have it here, not in this room, but I have it. um, if anyone's read it, you'll know what I'm talking about. But um, uh, I think there needs to be like an equivalent of that book, but maybe like a briefer one um, uh, for Rust and like what are the things you're going to do over and over again and apply to a bunch of different problems in Rust in a way that is idiomatic and you know will work for you.
Rust algorithms book saying.
Yeah, I mean my book itself is not all about design patterns, but I think that design patterns chapters are well I think they're the most valuable ones probably. But I would consider them like advanced topics for the most part. Um, so I wouldn't try to learn the Rust design patterns until you've got a good handle on the Rust language itself. Um, but once you do, then you can start to like, for example, use features like marker traits, which is like um, a way of constructing um, objects in like in a generic way and like apply different properties to them, um, which is something you'll see quite a bit like in other people's Rust libraries, for example. Um, and I don't know if anyone else has like made a collection of these design patterns and like written them up anywhere yet.
Yeah, I don't see a lot of this kind of material. Like, there's a lot of, I mean, there's a book out there called Zero to Production, and the author of that book is putting a lot of um, design patterns in terms of like how to make a system from end to end, how to structure your code, things like that, but not necessarily on algorithms. But that one I think is also quite valuable too because there's just no like, Rust is like a Wild West, right? It's not a framework, right? So there's no kind of clear set way. And even frameworks within Rust themselves, they don't think that really set patterns, right? If you look at like Actix or these other ones, I don't think there's anything there about, put your models over here, put your controllers over here, and everything just kind of works. Like I think on the other podcast you mentioned like what's the term? Not giving you a choice. I forgot what you called that one. Uh, you called it something. I
Uh,
forgot what the terminology is, but you know what I'm talking about, right?
mm, I'm not
Pre
sure
like
what you
pre
mean.
uh, when we talked yesterday, you were talking about you're a pretty big fan of people making choices for you.
Oh, like prescriptive, you mean?
Yeah, but there was another term that you used that I think is really straightforward for people. Convention over configuration, I think, is probably the more widely used term.
Yeah.
So like if somebody already puts the pattern out there and like sets everything up so that way if you follow the convention, you'll have everything that you need. If you go against
Right.
it, it may be more difficult. But yeah, there's no real conventions, I think, for most Rust programs. They just kind of work around you.
Yeah. Well, yeah. I mean, some of the libraries are definitely quite prescriptive. But yeah, I mean, the Rust language itself doesn't really impose that on you. Um, but I think like yeah, as when you spend enough time in Rust, you'll start to see that like these patterns emerge, and there are patterns that work, and there are patterns that don't work. And some of them are really basic, right? Like for example, you use derive, right? Like don't implement the debug like your debug print trace yourself. Just use derive debug. Um, that's like a really simple example. Um, uh, and like those kind of things you'll sort of figure out pretty naturally. Um, but at the same time, like I think there's something that is it's something that should be sort of written down, and you know I guess not everybody has to agree with it. I'm fine with people disagreeing with those ideas. But for someone that's like brand new to the language, or newish, like you don't really want to spend a few years just sort of like wading through a bunch of code to try and sort of discover the way, the right way, right? You're not like a Jedi training over a period of years or something. You want to just like get there quickly, and sort of skip the years of training, um, if you can, right? And so that's what my book is about.
Yeah, I mean, maybe we can start to wrap up over here. Uh, maybe for so like I said, the audience I think is quite interested in Rust, but I don't know how many people are actually using Rust. But is there any kind of tips or tricks you think that people should keep in mind when they begin on this journey?
Um, yeah, I would say. I mean, if you're brand new to Rust, um, good place or good thing to do is to make sure that you familiarize yourself with the tools like Clippy and Rust format and so on. Um, Clippy in particular can help you find bugs and stuff in your code that the compiler might not necessarily catch, um, before you ship code, and so it can save you a lot of pain. It can also just like find like common logic errors or like code that's unnecessary. I find that like sometimes Clippy, for example, will say like, "Oh, here's a piece of code that you don't need," or whatever, and I'll realize like, "Oh no, I do need that. I wrote this like, like my if statement is wrong, and that's why you think I don't need it." Um, and so in that sense, like it can help you find bugs. So I'd say that's like using Clippy, and building it into your workflow, like setting up automated checks, like in some kind of CI/CD system, uh, um, can save you a fair bit of pain down the road, hopefully.
My personal experience with Clippy, right? I can't exactly remember what it was, but for instance, I think what came up one time was something like I used like like the if let syntax, but did like an underscore for like in the name or something when I wanted to like see like if something worked, then do this block of code, but I wasn't actually using the wrapped out value, the unwrapped value. I think it was a result or something. I'm trying to remember. It's been quite some time. But what I found that I think Clippy told me, I'm pretty sure, I know it was something like this, but what Clippy ended up telling me was like, oh, yeah, sure, you can use this, but you should actually check out doing it this way, like using like dot is okay in the if statement instead of saying pattern matching on the value coming back out and just not using it. So this kind
Yeah,
of stuff will make your code more idiomatic, more easier to read, and more just straightforward, I think.
right. Yeah, and what's nice about Clippy actually is that it can actually automatically fix issues for you as well. So you can like run it with I think it's like dash dash fix or whatever, um, and it can like if you're trying to switch it on a big project for the first time or something, it might generate a whole bunch of warnings or whatever. And so like the first time you run it, you can just ask it to fix everything for you. And if it can fix it, it will. It's pretty similar to like the linters that you find in other languages, right? Like in the TypeScript, JavaScript world, there's a bunch of different linters as well, um, and I don't know if they're quite the same, but like it's pretty similar idea. And I'm a big fan of these tools because it means less work for you as a developer, basically, less to worry about.
Turn on ClickBM, my first project, the one we talked about with the XML parsing. I felt not, I want to say I felt betrayed by the Rust compiler, but not really. Like I felt like so surprised, like, whoa, what is all this stuff? What did I do wrong? And like I started looking at it, and I was like, wow, actually, no, I totally see why all these things were flagged. But I was just surprised that the compiler itself didn't catch this. But uh, it's actually not an issue of the compiler and all that stuff. It's more like finding better ways to do certain things. I'm not sure how to describe exactly what Clippy does.
Yeah. I mean, it's a good question. Well, I should mention that like Clippy is it's pretty configurable. You can sort of switch on and off different checks. Some of the checks might you might consider annoying sometimes, but yeah, for the most part, I think it's pretty helpful. I haven't thought much about like how how exactly it's designed or why or why the checks are not just built into the compiler. Um, my guess is that there's a good reason, and I think that if you like looked at tickets on or like GitHub issues from the Rust team, I think I've seen cases where like people are talking about a feature in the compiler, and they're like, well, maybe we should do this, or maybe we should do that, um, and then like it gets resolved by just saying like, well, let's just let it be, um, and then we can add a warning in Clippy or something, basically. Um, so I guess like what I mean by that is sometimes there's too much complexity to add it into the compiler, and it it may belong as um, a part of Clippy rather than in the compiler because it shouldn't be a core language feature, but rather it should be something that you can like switch on or off, um, depending on whether you want it. And so, Clippy itself comes with a set of best practices, um, but like the compiler will accept, a much wider set of things that work and are still correct, but might not actually be what you want, right? So like Clippy is a much more opinionated version. You could almost think of it as like there are two versions of Rust, right? There's the official Rust that will pass the Rust compiler, and then there's like the Clippy approved Rust. And the Clippy approved Rust is like a much stricter standard, um, that cares more about different things, I guess. Right? I'm thinking
Yeah,
back to like I don't know if you have ever used Perl, but like Perl used to have like this use strict. Like you'd see it at the top of every Perl script, and it was like it was basically like I don't even remember what it did exactly, but I just remembered that like there was like a strict subset of the Perl syntax that like everyone switched on because the non-strict Perl was like too crazy, I guess, for most people. So you could sort of think of it like that, I guess, maybe.
The way I look at Clippy is between Clippy and the Rust compilers. The compiler, like yeah, like you say, it just kind of compiles the code. As long as it follows certain rules, it's okay with it. It doesn't really care too much about how you write your code, as long as you write it in a way that doesn't violate its rules. And Clippy kind of takes a look at your code and says, you know what? You're doing this over here, but you're not using like for result type. You just want to make sure this thing succeeds. You don't really care about what comes back. But it could say, okay, instead of actually pattern matching and not caring about it, it makes much more sense to use this dot is okay or something like that kind of sort rather than saying, doing what I like the example I said. So it's more like, why don't you do this instead? Because you're not doing something with this. Like it's just more, it's kind of like a big brother or a more senior dev taking a look at your code and saying, why don't you write it like this since you don't need this part of it, or this one is much more clear, something like that.
Yeah, yeah. I mean, Clippy does stuff like find what I would call code smells. Like for example, if you have a function that takes like 50 parameters or something, Clippy will print out a warning and be like, maybe you shouldn't have a function with 50 parameters or whatever it is. I don't know what the limit is, but like there's some limit. And you know what? There's probably going to be a case where you need a function with 50 parameters. In fact, I know that I've had this case. Like sometimes it comes up, but most of the time, if you're writing functions and you have 50 parameters in your function, like that's something's off, right? It doesn't seem right. So Clippy will bug you about it, but like the compiler doesn't care, right? Compiler doesn't care how many function. I mean, there's probably like a hard limit on the compiler. I don't know what the limit is, but as far as the compiler is concerned, like if you want to write really messy spaghetti code, go for it, right? Like the compiler doesn't care. The compiler is just there to compile the code.
Okay. Maybe is there anything else you wanted to say before we really sign off this time?
No, I don't think so. Thanks for having me. I guess I hope that was valuable for everyone who's listening.
Yeah. Or there's also one last thing. Didn't you write something that you wanted to ask people to maybe check out?
Um, well, I
Your
mean,
book, right?
definitely check out my book. Yeah, it's
Yeah.
called Code Like a Pro in Rust. You can actually buy it now if you'd like. And in fact, I do have a discount code, which I should. I just forgot what it is. So let me just look that up really quick. Um, yeah, if you do want to pick up a copy of my book, you can use the Watch Matthews 40, which is WATCHMATTHEWS 40 at checkout, and that should give you a discount on the book from Manning.com, and so go check it out on Manning.com. That's it.
Also good for you guys to know too that if you're gonna buy the book, definitely buy it directly from the publisher because if you buy it from Amazon or something like that, I think there's less of a cut that goes to you because there's always a middleman somewhere, right? So
Yeah,
if you
that's
want to,
right.
I think there's you can see like a what do you call that preview or something. There's like a free chapter you can read or something for all kinds of books. So check out the free chapter if you think it's good and you're interested to buy it. Buy it directly from Manning because that more money goes to Brenden for working on it, and it's just worth it in the end. And then I think you get a little bit more like different formats, etc. Right? If you buy it from Amazon, you just get the Kindle version, etc. So you're better off going that way. Plus, You can only get the book now through Manning's because it's still in the MEEP, Manning Early Access Preview or program, where you can get a copy of the book and you can give some feedback about good or not. I gave one feedback. I feel happy about it. I found a typo somewhere, but I'm sure you probably corrected that a long time ago when I reported it.
I might have, yeah.
Yeah, because it's
I don't
pretty
know
straightforward.
if it's been reflected yet. There's a bit of a feedback loop, but a review cycle. But yeah,
Definitely. Okay, thanks for coming on. I highly appreciate it, and I hope that people find this episode useful. And yeah, so maybe I'll have you back again after you finish the book to talk about, how good, more about the pieces of the book later on, since it's still not all out yet.
yeah. All right. Thank you.
Thanks.